Alright, let's take a look a little further at some of our assignment here from today, Wednesday. This is lesson 1.5, and we'll look at a few problems here, and hopefully this will help you as you're doing your homework tonight. And problems 1 through 3, they want us to sketch the function and identify any possible points of discontinuity. So, I guess the only dividing line is at x equals 3. This piecewise function defines the function to equal 9, so that's my y value. And 1, 2, 3, 4, 5, 6, 7, 8, 9. There's just a dot right here. And then everywhere else it's going to follow the top of this piecewise function, the first function that they define, which is this x to the fourth minus 81 all over x minus 3. I don't know why I circled the first part. But anyway, let's see if I can erase that. There we go. So, looking at this, I need to figure out that, of course, at 3, it's not defined because if you put a 3 in for x on the denominator, you're going to get a 0. And for that matter of fact, 3 to the fourth power is also equal to 81. So you get a 0 over 0, and that's undefined right there. So let's look at the numerator and see if we can factor it. We notice that we have x to the fourth minus 81, and both of these terms have a perfect square, don't they? So it's a square minus a square. So let's see if I can find some real estate here to work with. We have x squared minus 9, and then we have x squared plus 9, and it's all over x minus 3. And of course, the first factor that we found also is a square minus a square, so it factors to x minus 3, x plus 3, and the rest of the numerator, we're going to leave it alone. And so right now, it looks like at 3, we actually can remove this discontinuity. So we'll just cancel that out. And now we'll see that this function does have a value there. So what are we going to do? Well, let's write down what we have left in our first equation. We don't really have a numerator, or excuse me, a denominator anymore. So how about we check out what happens at 3? So if I plug in a 3 directly, I get 3 plus 3, and we have 3 squared plus 9, so we have 6 times 18, which equals 108, I believe. And at that value, you can clearly see from our graph that it's going to be way up here at the top somewhere, right? Even though it's not defined at that spot, that's sort of what it's going to go through. Well, this problem, we probably have to put this in the calculator to see what's happening. So let's go ahead and put that in there and see if we can maybe figure out a little bit about what's going on. I'm going to put the original function in. So I have x to the fourth minus 81 in the numerator. So notice I'm going to put parentheses around that. And then I'm going to put in the denominator, x minus 3 in parentheses as well. And you can see that in a normal window, it doesn't really fit in very well. So let's try a zoom fit. See if it. So if we do a zoom fit, we can see that this thing kind of makes an S shape. In fact, let me take a picture of that. And so since this is just a sketch, so that we can state the discontinuity, what happens here? Well, it looks almost like a cubic function. And if you think about it, when we get to 3, we're going to have a hole in this graph, right? So I guess we just need to, well, we've already figured out what the value is there, right? It's 108. It's not really drawn to scale, but so basically all we need to do is sort of graph it like so. And that's really all we need to answer the questions. So what is the limit as x approaches 3 from the left? Well, as x approaches 3 from the left, it is not equal to 9 because at 3 exactly it's equal to 9, so that's the blue dot. So this value is just going to be 108. So if we look right here a little closer on the graph, you can see that as we approach it from the left, we're getting to 107.8, 1.9, and then we get to 108. And as we approach it from the right-hand side, it's going to be coming down this direction, and it's also going to be 108. So even though the function value in this piecewise function, f of x, is equal to 9 because of the rule right here, but the limit is 108. And so where is it discontinuous? It's discontinuous at x equals 3. Okay. Hopefully that'll help you a little bit. Let's see if we can do this next one here. Try to keep this video relatively short. The next problem says, still part of the sketch, right? Well, certainly this would have to be a calculator problem. So let's go ahead and clear this function out and do a 4 minus 1 over x plus we have x squared divided by, put parentheses around the denominator, x minus 5, and let's always start off with a zoom 6, and that kind of gives us a little bit of a understanding of what's going on. This is a pretty crazy looking graph. So let's take a look at this. And let's get rid of what we had before from the previous problem. Okay. So what's happening here as we sketch this graph? As we sketch the graph, we can see a couple of things. First thing I'd like to point out is if I make x equal to 5, it's going to make that denominator equal 0. So we know we have a point of concern at x equals 5. So let's just identify it right here, and we'll identify it by making a dotted line because we know it has an asymptote there. We can see that from the graph right here, like so. And what's the other spot that would cause the denominator to go to 0? Well, that's when x equals 0. So when x equals 0, it's kind of hard to see this, but we also have an asymptote right at 0. And you can see right here that the function looks like it starts to approach infinity as we get to 0. As we get to 0 from the left. And then on the right hand side it does something kind of funky. I'll see if I can change colors, see if yellow shows up. Yeah. So in between the two asymptotes, it sort of has this little hump shape here. So we'll draw that one in there as best we can. Remember, we're just going to use this graph to help us with the limit questions over here on the right. And my calculator didn't show me what happens over here to the right of this asymptote. So let's go back to it and see if we can pull that function back up and maybe do a zoom fit. Maybe that'll help us. Yeah, it kind of helped a little bit. See this portion right here? I can't see it now. See this portion right here? It looks like it's going to positive infinity over here to the right hand side of x equals 5, and then it approaches the x-axis somewhere along here. So we don't really need it too much, but I'll go ahead and draw this portion. I don't really know exactly what it's doing, but something like that perhaps. Well, fortunately for us, all we care about is looking for the limit as x approaches 0 from the left. So as we approach 0 from the left, I'll try to highlight for you. Let's choose a different color. Choose green. We're starting to come up, and you can see that our highlighter is telling us that we're heading towards positive infinity. So let's go ahead and identify that. Positive infinity. And then we're looking at 5 from the right. So 5 from the right, here's 5 on the right hand side. We're coming in this way, and we're starting to approach positive infinity as well. So let's see if we answered all the questions. They also asked us, where are the discontinuities? We already kind of talked about them by drawing the asymptotes, but we didn't identify them on paper. It's discontinuous at x equals 0 and x is equal to 5. Alright, let's see if we have time to make another one here in a minute. I hope this